13.4 gives us one way to find the area of triangles and also the law of sine, which is a useful tool. We'll start by finding the areas of triangles. Now here I have a regular ABC triangle with sides ABC and angles ABC, and this has no numbers attached to it. It's not a right triangle. That's an important thing to notice. Moving forward, the trig we do doesn't have to just be right triangles. If I wanted to find the area of this triangle, I would need to know the height of it. So if I take this altitude, this height, and drop it down right here from that point B, I've split this one triangle into two right triangles. All triangles can be split into at least two right triangles. So this is now my height. I want to find the height of that blue line, find its length. Well, using trig, if I take this angle A, I know that the sine of A would be h over c, opposite over hypotenuse, h over c. So I wanted to find h itself. C times the sine of A gives me the height. Well, I know that the area of a triangle is 1/2 times base times height. The base in this case is actually B, so this is really 1/2 times the base times the height, and the height was C sine A, so I substitute C times the sine of A, and we get that the area of this triangle is 1/2 BC sine of A. And you can find the area of a triangle just by following that formula. We actually have one for each angle. Basically, if you're given angle A to work with, angle B to work with, angle C to work with, it doesn't matter, but what you're looking for is a side angle side triangle. So we're like a side angle side triangle. Whenever you have side angle side, you can follow this method. So I have a side angle side triangle down here. To find its area, it doesn't really matter which one's letter A, which one's letter B, letter C. Those letters don't matter at all. All these formulas are doing the same thing. They just rearrange it for letters based on which angle you're given with. But basically, if I do, the area is going to be 1/2 times 9 times 8 times the sine of 104. Make sure that your calculator is in degrees because that angle came to you in degrees. So we'll do 1/2 times 9 times 8 times the sine of 104. There, that triangle is 34.9. Whatever the units are, inches, meters, whatever. Units squared, square units. The law of sines, now instead of finding areas and we're able to solve triangles, law of sines is one of the first ways that we're able to solve non-right triangles. Remember, solving the triangle means you're going to find all the missing angles and all the missing sides. This isn't a right triangle, so our basic sine, cosine, tangent trig doesn't work. But there's a law called the law of sines. It tells you the sine of A over A equals the sine of B over B, which equals the sine of C over C. You only ever need 2 of those at a time. You won't use all 3. They just give you all 3 so you know that it works for all 3. And again, the letters here don't really matter. You kind of just make them up as you go. So if I call this A and this B and this C, and now which one's A, B, and C doesn't matter because they're not right triangles. Well, the key is I have an angle-side pair. I know an angle and its opposite side length. If you have an angle and the opposite side length and one other piece of data, you can always do the law of sines. So now I can say the sine of 50 over 16 is equal to the sine of 41 over C. This will be side C. And in this way I can find side C. I did sine of A over A equals sine of C over C because those are the 2 things I had to work with in this case. I just had angle A and side A and angle C. So I went with those. Now this is a proportion, so I can solve by cross-multiplying. When we cross-multiply, we'll get sine of 41 times 16 divided by the sine of 50. I'll actually write it out a little bit, but we get 16 sine 41 equals C times the sine of 50. Divide both sides by the sine of 50, and 16 sine 41 over the sine of 50 equals C. Be careful with your parentheses here. 16 sine 41, close parenthesis, divided by sine of 50. That missing length was 13.7. So this C here is 13.7. Now we have to solve the triangle, so I have to find this side length down here. But I know that because 50 and 41, these angles are going to all said and done add up to 180. So 50 plus 41 is 91. So this angle here is 89. And I can just do law of sines again. Always work with the original ones you were given. I'm not going to use the 13.7 and the 41 because I just found those, and they could be rounded, or there could be a mistake somewhere. I know the first two I was given were correct, so I'm going to work with those. So sine of 50 over 16 equals sine of 89 over b. So I'll do sine 89 times 16 divided by sine of 50. And that's 20.8. You should always check to make sure that the smallest angle is going to the smallest side. So angle C was the smallest angle, and it's going to the smallest side. Angle B was the largest angle. It's going to the longest side. So that's all good. One more. This time I'm going to find this angle over here. This is the only angle I'm able to find. Again, doesn't matter how I label this. If I go A, B, C, well, I have angle C, side C in a pair. These ones I know. So I know the sine of 35 over 110 is going to be equal to the sine of B over 90. I need to find B. Well, again, it's a proportion, so I can start by cross multiplying. And I get 90 times the sine of 35 equals 110 times the sine of B. I'll divide everything by 110. And I'll calculate that left side now. 90 times the sine of 35 divided by 110. And I get that 0.469 is equal to the sine of B. Well, that 0.469, that decimal, should give you a strong indication. So we're trying to find an angle. We're going to do an inverse sine. So if I do the sine inverse of 0.469 and do a sine inverse of the sine of B, the sine inverse and sine kind of undo each other. They cancel each other. So the inverse sine of 0.469, I'm just going to do the previous answer to be as precise as I can. The inverse sine of that previous answer is 27.9 degrees. 0.98 degrees, so we're just going to call it 28 degrees. So this angle here is 28 degrees. Now that I have this angle at 28, I can find angle A, because I do 180 minus 28 minus 35. Which is 117. Then I can do sine of 117 over A equals sine of 35 over 110. At this point, hopefully that proportion pattern is coming back to you. I can just do sine 117 times 110 divided by sine 35. 170.8. 87, so 170.9. Biggest angle, biggest side, smallest angle, smallest side. So this should all be good to go. Thank you.